Start with the questions, and I'll take
Yeah.
the first question. So the question is, does full CI not take care of both static and dynamic correlation?
Yeah, I saw that question.
Uh-huh.
Let me say yes. Of course, if you do full CI, I must say that everything is taken care because full CI is an exact method. So you don't need to distinguish static and dynamic correlation. The reason we do distinguish is because we don't want to do full CI, because full CI is too expensive, and thus we want to take limited CI, linear combination, where required for static correlation, and the rest by dynamic correlation. So I hope you understand. So we need a combination of static and dynamic correlation, and we don't want to do full CI. But the static correlation is indeed taken by CI type of approach, which is linear combination. And that is what I meant. And dynamic correlation is best taken care by coupled cluster, the exponential approach. So this is what I mentioned. That's the reason multi-reference coupled cluster is the best method. But indeed, if you do full CI, everything is taken. So the answer is yes. Full CI will take care of both static and dynamic correlation.
Okay, thank you, Professor Pal. So moving on to the next question. So is it possible to have computational techniques for materials to every technique such as electrochemical, chemical, physical? Because the person who is asking this question is an experimental chemist.
So what is the question?
So the question is it possible to have computational techniques for materials or for any other kind of technique such as electrochemical reactions, chemical or physical properties?
Yeah, so it depends on so it depends on the what kind of property you want. Of course, yeah, one can try to look at, but everything is not going to be very easy to do. So it depends on what materials and what property you want. But for example, if you want to do electrochemical synthesis and you want to predict by computational chemistry, in principle, yes, but it is not very easy to do because we need to find out how the synthesis many other properties. But if you want to just get electrochemical properties, yes, it is possible to do. So, and when you say materials, of course, the material is very complex. Then the techniques will become extremely difficult in the technique. So, yeah, I mean, the answer is, yeah, for in many limited cases, we can do that, but in not all cases today. But it may be possible in principle.
Yeah.
Yes.
Thank you, Professor Pal. So moving on to the next question. So the question is, mostly we are adsorbing some atomic clusters above surface slabs or any 2D sheets. But I am personally facing very difficulties to convince even to my mentor, as he's always commenting, he is very skeptical about this few atom clusters. So this is something, some kind of suggestion the researcher is seeking from you.
Yeah. So yes, of course. I mean, the point is that you have to balance. If you take very large cluster, then as I told you, your computational method will suffer. Right. So that is the reason you have to balance between what I call method and the model. Ideal thing would be have perfect for everything, but that is not, that is not very easy.
Yeah. Yeah. Thank you.
There is a chat box question. Can I take this? No. Okay.
Yeah, please take if
so somebody has
you are
written
comfortable.
The question was that have I used time-dependent DFT, the Amsterdam DFT? The answer is no, I have not used. But I'm aware of the Amsterdam DFT, and I have used TD-DFT for certain reasons, but I myself do not work. Maybe certain benchmarking, I required some numbers, so that's when I did TD-DFT. I also want to take up one question before I move, before we move forward. This is from Remy Fenniton. This is from my friend Tronsai. So I want to, it's a little technical question. He talks about the, let me see, where is this question? Tronsai, he talks about the wave function based correlation methods use Slater determinants as the n electron basis. However, when inspecting the resulting wave function, it is expanded in a very large number of Slater determinants, each of them with very low weight. Maybe a challenge is to find n electron basis function that, yes, I mean, that lead to more compact wave function. So what essentially Trond is telling, I want to explain that I talked of challenge of how to sum up so many determinants in a dynamic correlation. So what he's saying that instead of using the current basis sets, can we look at some basis sets which will have very compact wave function? Indeed, Yeah, I mean, I agree. That's a challenge. I should put it down. Uh, in fact, already many people say that the Kohn-Sham virtual orbitals are those orbitals which will squeeze the number of determinants. I'm not very sure about it, but I have heard this, and many people are looking at the Kohn-Sham virtual orbitals be used as in the basis set. But your point is very well taken, and I agree. This is a challenge. So I think I took these two questions because they were more, they were more technical questions, and
Yeah, so
yeah.
thank you
So
so
you can
much.
continue.
Yeah.
We can continue now.
Thank you, Professor Pal, for taking up the questions. And again, we'll move to our other questions. So apart from QM, MM, what are the other
Yes.
multi-scale approaches? Can
So
we connect?
I already mentioned this in my talk that quantum mechanics is the lowest length scale. There is atomicity, which is called molecular mechanics, and then there is a coarse graining. So that is called the mesoscopic simulation. So that is another one, which is sometimes called CG. So you can have a method which is QM, MM, CG all together, and that would be great actually. So basically, the coarse graining, the idea is the following: that you take a group of atoms and make a bead, and then that bead acts on another group of atoms. So basically the degrees of freedom among the atoms are also frozen. In the atomistic simulation, the electronic degrees of freedom are frozen. Atom is an individual particle, where a group of atoms will become an individual particle in coarse graining. So that's the next level of multiscale simulation. Yes. So it is possible to go beyond QFM.
Yeah. So thank you, Professor Pal. As we can see, there are some students also. So
Yeah,
they are trying to have some insights from you around
sure.
some of the computational chemistry basic books that is important to build the understanding in this field.
Yeah, I
So
think there is a book by Allen and Tildesky, which is very good, which you can read. If you just do Google search, you'll get it. But yeah, I mean, if you just do Google search, you'll get several computational chemistry. History is very old. In fact, starting from the methods of electronic structure theory, Plenum Place by Henry Schaeffer edited, which we read in 1977, I must say.
yeah.
There are several books, but I think I can quickly say Allen and Tildesky is one book that you can read.
Yeah.
Somebody has asked, I think Kankana Bhattacharya, how can one calculate binding energy using quantum mechanical method? Yeah, this is, of course, a very simple way to do is to calculate the energy of the bound system and subtract the energy of the individual systems. So you get the binding energy. That's a very simple thing. But this is not a direct difference. So it would be very interesting. Your question can be very interesting if you ask, can we calculate the binding energy in a direct manner? Just like equation of motion methods give you ionization potential, affinity in direct manner, or couple cluster, for example. So that would be a very interesting thing to do. But most people are doing by subtracting these energies, and that's easy. So let's say I have a binding energy of HF dimer. So you just calculate HF dimer energy, then subtract the two HF energies. Of course, you need what is called the BSSE, basis set superposition error. There's a BSSE error. That's also a very standard thing. So today you'll find that in any standard package, BSSE. So yeah, quantum mechanical methods are very well developed for binding energy. So if there are further questions, you can contact me.
Yeah. So again, we are running out of time, Professor Pal, and I would like to request if
Can
you
I
can
take
take.
some of the questions
Yeah.
very quickly?
Yeah. That's why
question.
I just wanted to request that if you could take some more questions.
Yeah, I can take the quickly.
Yeah.
G.
Thank you.
Reddy. For simulated lowest energy possible water clusters, can you do fragmentation by using CCSD method? Yes, I mean, that is going to be a problem. I agree with you. But in principle, we can try various water clusters. But we can do, because you have, let's say, water dimer, water trimer, water. So if you have a good fragmentation approach method, then each of them we can actually do. So that should not be a problem. But yeah, I mean, the fragmentation methods are not that well developed that I can comment whether we are going to miss the lowest energy structures or not. Arijit Bug, possibility of using of artificial intelligence in ab initio quantum mechanical method. Yes, a lot of people are looking at that because it can actually speed up, but it is not very clear. Yeah, I mean, it is not very clear how to use this. I must say this, The ab initio quantum theories are physics-based, theory-based, and of course, the artificial intelligence is to really kind of extrapolate. So wherever we are not able to do things, so for example, if I have a singles, doubles, triples, and I want to have an extrapolation of the T4, Hassan Shoiga, I will come to that, your question. Yeah, so T4, can you extrapolate from the results of T1, T2, T3? Can you extrapolate to T4? That would be a good way artificial intelligence can be used. So there are several. I'm just giving one example. Dynamics also, there are several examples. Somebody said whose questions are not answered. I don't know his name. I'm not finding. Hassan Shoiga. Since he's a little bit impatient, I will just answer his question first. I'm new to computation. Can proof suggest or does ACS as a workshop and materials computation and numerical simulation for beginners? Yeah, maybe Diksha, you can answer this.
So yeah, of course, in future we'll think about this, and again inviting people like you as the speakers, and again based on your recommendation, we could have some people to have these kind of thematic seminars. Yeah, thank you so much.
Diksha, I know we are getting late, but I think I'll try to close in 5 minutes. Yeah.
Just please take your time.
It's okay.
I don't want to interrupt you because I know how much you are enjoying it. So definitely we are pretty much here. Please take your time. It's just I wanted to say thank you so much. This is really even I mean, even at this level of busyness, you are, so enthusiastic. So I'm like really impressed seeing it. So please carry on.
Sure. Thank you. Those who are writing chat box. Thank you, Vidya, for your appreciation. Let me go to the next one. For polymeric materials and nanoparticles, is it possible to do computational chemistry related studies? Yes, of course. There are a lot of work on polymer materials and nanomaterials with not exactly using quantum mechanics, I told you. Maybe atomistic simulation and coarse graining. Yes, of course it is possible. If both physisorption and chemisorption owned work for hydrogen storage, no, I mean, what we meant was that physisorption and chemisorptions are not ideal, but we want to come to a system which is neither physisorb nor chemisorb. So when I said scandium decorated MOF, it was a physisorb system. MOF was physisorb, but once I put scandium, its hydrogenation energy increases. So we have to come to a new kind of adsorption, which is neither physisorption nor chemisorption. So indeed, it's a challenge, but people are trying to do that. And today I can say that we might get good results. I mean, because we want room temperature hydrogen storage, maybe 7 to 8% gravimetry. So people are looking at 2 to 3%, and I think it might come. Computation should give, and I think we should keep trying. We have not yet got the material, if that is the answer you have. Always the theoretical analysis gives a high percent result, but experimentally that is not achievable. That is sometimes true if the theoretical methods are not very reliable, but if theoretical methods are very reliable, indeed experiments, they can be predicted. I did not tell you about a very interesting work in the early days of methylene. There's a very interesting story of methylene where the experiments predicted something and the theory predicted something else, and theory was eventually right. So that was a very interesting story of methylene. I didn't want to say my good friend Henry Schaefer has been a part of this, actually, the development. So I think I'm quite enthusiastic to say that in some years we'll be able to predict experiment. What is the future of quantum chemistry method development in India? Well, I must say that I am a bit disappointed. Many people are moving to computation and not development of theory. But I think India has a good base. So if we do cultivate, if we do propagate, there is a future. Many people think that there is not much to develop, and that is the reason people are moving to computation. Or is it the easy way to work? I don't know. But I believe there is a scope to still develop quantum chemistry. And I think although at this stage we are not in a great stage, I still believe the future should be good, because we were at some point of time, India was very good in terms of development of quantum chemical methods, and maybe 20, 30 years back. All right. So as Fox-based couple cluster, and the many problem like intruder, Manisha writes, analytical pilot application, why can't we do UMCC method? Absolutely, you're right. So you are absolutely right. UMCC is a very good deal, but in the Fox-based couple cluster method, if you go to third order property, that is completely size extensive. So to do UMCC size extensive, we have to do similarity transform, ST-UMCC. So I think this, so there is a, this is a good question. I mean, this is a question that we keep on doing. Is there a necessity to Fox-based couple cluster? I should also say that if you go to excited states, which is one hole, one particle, or two holes or two particles, the Fox-based differs from UMCC. However, if I do not develop one valence Fox-based, you cannot do two valence. So I just want to argue that it is important still to develop Fox-based. Intruder state problem in the Fox-based, people are trying to, have tried to solve in many ways by using intermediate Hamiltonian. I must say that again, I did not get time to mention that. So yeah, I mean, but your point is taken that there is UMCC is a looks like a simpler method in many cases. Yeah. For the transition state simulation of periodic models, the boundary condition defined is the boundary confined for such calculation. Yes, of course. If it's a periodic model, we are working in a boundary condition. What can we do AI mechanism by using DFT, TDDFT? Yeah, probably yes. I mean, I've not worked on TDDFT, but probably yes. Again, if I'm interested in quantum biology as a chemist, I told you about the Allen and Tildesky's book. That is very good. You can read it. I think even for computational biology, it will be very good. For CO2 oxidation, Harjit Singh, why people are working with gold cluster will be very difficult to implement at the industrial scale. Yes, I agree. Gold is, of course, expensive. So indeed, there is people are working on gold cluster because they're very effective. I must say that. But I take your point that to implement at industrial scale, we need cheaper catalysts. In fact, that is the most important part in the catalyst development. If you look at our carbon dioxide activation also, it has been the same story that we're trying to look at a cheaper and cheaper catalyst. Can you tell the steps to form a lab? I didn't quite understand. Nirbhai Singh, can you tell the steps to form in lab, step to step, that will be the best? I don't really understand the question, Nirbhai Singh. So I will just now pass on. Then anonymous attendee, when simulating or designing material through computational chemistry, how important is it to consider the synthesis method? Yes, of course. Synthesis is very important because unless whatever I design is not eventually synthesized, then there is some problem in my design, right? Either the method or the model. So indeed, I mean, it's very, very important to consider. I mean, the synthesis, for example, when I'm looking at barrier in a reaction mechanism, that is for synthesis. If the barrier is too high, it will not be synthesized at a given time. So indeed, the computational methods are to help the synthesis. I would rather put it this way. So you don't need to consider the synthesis method. Computational chemistry can be done ab initio. Please understand. In the first principle, that is the reason I put a title, first principle computational chemistry. But then that can help the synthesis. So these are very provocative statements, but that is what will happen in next few years. Let's see. What is the other thing? What is the scope of open Hamiltonian systems for simulating reaction dynamics? Yes, I will. Yeah, this is a little bit more technical question. I will pass on, but those who are interested can contact. I did not talk of reaction dynamics. In this talk, I mostly talked of electronic structure. But yes, I mean, this is a very interesting question. Yeah, what software I'll use for CC calculation? Oh, there are plenty of, depends on what you want to do. For the CC calculation, there are plenty of software for standard calculations with the single reference couple cluster, with equation of motion couple cluster. But the kind of things that I talked of, Fox-based couple cluster, there are not too many softwares which are used. So we are developing. There are not that many softwares which are all available in the Hilbert space couple cluster. There are some software which is available. Okay, so like C4, and there are many other softwares which you can actually read. But again, what we are developing is something new. So many of those softwares are not developed because we have just done it. It is with us as a software from our group, but this is not really put in the canned software. I should put many of these in the CAN software so that it becomes much easier to use. Yeah, but starting from Gaussian, standard couple clusters starting from Gaussian, there are several software, EMS, Gaussian, C4. I mean, you can get it, any number. Yeah, then there is a question by Srinivasa Hariharan. Could you, what is that question gone? Could you comment on the predictive capability of ground state DFT, static DFT calculation for heterogeneous catalysis? Context of it has been shown that the active sites are dynamic and anti-harmonicity plays a role. What could be the... Yes, heterogeneous catalysis, I must generally say, heterogeneous catalysis are much more difficult to describe by DFT, or in fact by any method, because model itself is very complex. Very complex. So I agree with you. What we are developing is mostly homogeneous catalysis. And then we can go to a synthetic chemist who will try to do heterogenize. And the industries are interested in heterogeneous catalysis. But your point is absolutely right, that any calculation of heterogeneous catalysis is very difficult. I think most of the question I have answered. And thank you for other comments which people have given, appreciating the talk.